When we have numerical data, we can describe center and spread using the median and the interquartile range. The median is just the middle value that divides the data into two equal halves. So the median is a location within the data. It's a data value that divides, whereas the mean is an actual calculation of center. So that's the main difference between the two, where they're both describing center. Median's just a location, where mean is a calculation. So there's two different ways of finding that median, and just kind of depends on how many data values you have. When you have an odd number of values, what's going to happen is when you move towards the middle, which you can do by kind of thinking, okay, we have those end values, takes those off, and move towards the center. And so for this data set 3, 8, 12, 15, 18, to move to the center, we're going to land at 12. That right there is our median. If we do the same thing with an even number of values, what's going to happen as we move to the center, kind of marking off those as we move to the middle, we're going to end up between two values. So for this data set, we're between that 12 and 15. So in between there is our median. And what we do is average the two. So if we're between 12 and 15, take 12 plus 15, divide that by 2, and that average is our median. So in this case, 13.5. So that's how we find the median for these two different cases. It's an act of just moving towards the middle. It doesn't matter what numerical values are on the end, you just get towards that middle to find that number. So with this method of finding the median, let's compare how mean and median would compare in different distributions. So in a symmetric distribution, or really for all of these distributions in terms of the median, you want to look at the peak of the data. So for each of these, if I look for the peak, that's where the median should be landing. So for the symmetric distribution, it's right in the middle. For a skewed left distribution, that peak is to the right-hand side, so the median should be somewhere in there. And then when it's skewed to the right, there's the peak to the left-hand side, so our median would be somewhere in there. With the mean, this is where you want to think about what's happening as you average the data values. So with a symmetric distribution, you're going to land right in the middle with that median. So if I use X bar for the symbol, it's going to land at the same spot as the median. So for with a symmetric distribution, that mean and median should be about the same. They should be very close by. Maybe not exactly the same, but close enough, and that suggests a symmetric distribution. If we're skewed to the left, so this would be an instance where when we're adding up our values for the mean, most of them are on this high end, but we have these few very small values. This is a case where we probably have outliers, and outliers skew the mean, and they pull the mean in the direction of the tail. So with a symmetric distribution where mean and median would be exactly the same, if you have this tail to the left, the mean gets pulled to the left of the median. So in this case, with the skewed left distribution, we'd have the mean to the left, median to the right. And what this would mean is for a skewed left distribution, our mean is going to be smaller than our median. And with skewed right, similar idea, it's that now our tail's to the right-hand side, so this would be an instance where we have a lot of small values, then we have these few extreme, very big values. And where mean and median are usually the same in a symmetric distribution, that mean's going to get pulled to the right-hand side of that median, so it's going to land above. So for a skewed right distribution, your mean's going to be significantly larger than the median. So with this, with seeing these distributions, the peak is a good idea of center for these distributions and what's happening, what's expected. So the mean's getting pulled around based on those skewed distributions, and that's not a good measure of center then. If they're being skewed by these few very large or very small values, we don't want that to be part of describing our expected value. So with skewed distributions, that median is a better descriptor of what's happening, not on average, but what's expected for our data. Whereas with the symmetric distribution, that mean's going to be the best case. So for skewed data, when we want to describe center and spread, and right now we're talking about center, we want to use the median. If it's symmetric data, then we want to use the mean. For describing spread, what was attached to the mean is when it's a symmetric distribution, then we'd use standard deviation to describe spread. With these skewed distributions, we want to use something called the interquartile range, which is what we're going to talk about next. To get to the interquartile range, we need to understand the quartiles first. So quartiles, it's separating our data into quarters. So we want to imagine we have all of our data. If we cut it in half, then it's 50-50, and then we just want to cut in half. So we have these sections that's just collecting 25% of our data. So we have these 4 sections that each contain 25% of our data. Now, what the median does, that's our middle value, and that would relate to having the 50th percentile. That word percentile is just describing the percent of data to the left. So we have 50% of the data below that number. So if we have this kind of separation into quarters, this middle part where we would have 50% to the left, 50% to the right, that would be our median. And looking back at data set A and B, data set A, we can see we have 50% below, 50% above. So 2 data values below, 2 data values above. So you should have this even number of values on either side. Same thing with data set B. This barrier is kind of between 12 and 15. We have 3 data values below, 3 data values above. So we have this even distribution of values there. Then we have the first quartile. So the first quartile is marking the 25th percentile, which means there's 25% of the data below that number. So if we have this separation into groups of 25%, that first quartile is happening at this first separation. So we have this lower 25% and this upper 75%, and that's where Q1 occurs. So to find Q1, if we go to data set A, it's the idea of what if we ignore everything to the right of the median? And in fact, the median itself, it's like that's going to act as a barrier between these 2 groups. So if we only look at this lower end of data values, we're essentially finding the median of just that set. So where we just have 3 and 8, we want to find the middle, and the middle is occurring right between 3 and 8. So this middle between 3 and 8, that would be Q1. And to find the actual number, we just need to average 3 and 8, which is 5.5. So that would be our Q1. And with data set B, same idea. Our barrier is happening at this 13.5. So our lower part of the data set is this 3, 8, and 12. So just with those values finding the middle, if we move towards the middle, take out that 3 and 12, and that 8 itself is our middle value. And that would be Q1 for data set B. For the third quartile, this is going to be at the 75th percentile, so where 75% of the data is below, and that's happening at this separation above the median, such that we have 75% below, 25% above. That's going to be our Q3. So to find Q3, it's kind of like finding Q1, it's just now we use the upper values. So for data set A, that would be the 15 and 18. So we want to find the value that's in between those 2, and that would be our Q3. So if we take 15 plus 18 and divide by 2, that's going to tell us Q3 is 16.5. And for data set B, using just the 15, 18, and 20, moving towards the middle, we'll be landing exactly at that 18 for Q3. So those are our quartiles. And can see with the separations with data set A, We have one data value in there, one there, one there. It should be an even distribution in terms of the number of data values that are between the separators for Q1, median, Q3. Same thing happens with data set B. There's one data value in each group. It should be an even distribution with your data set. So getting these values together, how we like to summarize these quartiles is with a 5-number summary. And you can represent it kind of as a coordinate. If we start our parentheses, you want to describe the minimum, your first quartile, your median, your third quartile, and your maximum value. Those 5 numbers offer a really thorough summary of what's happening with your data. So if we do that for data set A and B, for data set A, our minimum value, so the smallest value is 3, Q1 is a 5.5, median is 12, Q3 is 16.5, and maximum, the largest value, is 18. So that would be our 5-number summary for data set A. For data set B, minimum of 3, Q1 of 8, median of 13.5, Q3 of 18, and maximum, our largest value, is 20. So these 5-number summaries summarize the main features of that data. The range is a way to describe the distance between the minimum and maximum value. So this is a way of getting at describing spread. So you just take your maximum value minus the minimum value. So for data set A, to calculate the range, we would be taking 18 minus 3. So that group has a range of 15. And for data set B, our range would be taking 20 minus 3, which is 17. However, when calculating range, you can see we're using our maximum values and our minimum values, and that's where any outliers would be occurring. If it's a skewed left distribution, our minimum would be an outlier. If it's a skewed right distribution, our maximum would be an outlier. In terms of describing spread of the data, it's not the best measurement when you have outliers. When it's a symmetric distribution, it's great, but you don't want your values influenced by those outliers because they're extreme scenarios. So the range is nice for symmetric distributions, but just keep in mind that it's influenced by outliers. So we want to be careful using it. Instead, with our skewed distributions, we want to use the inner quartile range. So it's a way of finding a range, but it's just for the middle 50% of the data. The middle 50% of the data is the important stuff. So we take our Q3 minus Q1. So for data set A, what that would look like, finding this inner quartile range, you take 16.5 minus 5.5. which is going to be 11. And for data set B, that inner quartile range is going to be taking 18 minus 8, which is 10. And this is a much better descriptor of spread if there are any outliers. So our inner quartile range is not influenced by outliers. So when we have a skewed distribution, we want to use median to describe the center of the data and this inner quartile range to describe the spread of the data.